Well, here we are for the last chapter of CCNA 2, Chapter 10. Very short chapter on device discovery, management, and maintenance. While the PowerPoint slides are short, there are a few concepts that are important here to go through in a couple commands. So even though the slide deck is short, it's not necessarily the simplest chapter in the world. So the topics that we will be going through in this chapter are device discovery protocols like CDP and LLDP that allow you to discover what devices are in your network. We've got network time protocol and Syslog, as well as backing up your iOS files and managing them through a TFTP server. Okay, so those are the things we'll be looking at. Again, short list, but there's a few commands that are involved. So first thing we'll look at is the Cisco Discovery Protocol. So our first discovery protocol, our first discovery protocol of the two, is Cisco Discovery Protocol, and as you can maybe conclude from the title of this protocol, it only works with Cisco devices. So it is going to it's just going to be proprietary. Okay. The other one, link layer protocol, the link layer discovery protocol, is going to work with any type of device. So you've got that type of situation going on. So again, this is Cisco Discovery Protocol, only works with Cisco devices, and through Cisco Discovery Protocol, you've got layer 2 messages going back and forth, basically advertising which device is connected to your device. Okay, so this router would know about this switch through CDP, and the switch would send advertisements to the router letting it know who it is and what it's capable of. Okay. By default, CDP is enabled on all your Cisco devices, so you'd have to turn it off if you didn't want to send those advertisements. Okay, some commands to configure and verify CDP. You've got show CDP neighbors, which is going to do just that, show your CDP neighbors and information about them. And you can show your CDP interfaces to see which interfaces CDP is enabled on. Some examples of that, you've got the show CDP neighbors command here. For instance, we've got S1 doing a show CDP neighbors, and you can see it's connected to S2, which would be this one we don't know about over here. So if you didn't know about this device, you would now. Through a show CDP neighbors, you can see it's connected through fast Ethernet, yada yada, on your device. Hold time is basically the time that it's held in a table. Capability will only worry about the S or the R, that just means switch or router, and the port that you're connected to on the other device. Okay, so we're connected on this switch over here through fast Ethernet 4. Then we've got our router, same type of situation, fast Ethernet 5, R here for the capability, on port gigabit Ethernet 01. So we're connected to that guy up there. Again, switch 2 would be over here. In this example, they're showing us that we don't know what this guy is, and we could do a show CDP neighbors to figure that out. Okay. These other commands, CDP run, you've got that command to enable CDP globally on your entire device. Okay. Again, CDP is enabled by default, so if you wanted to turn it off on the entire device, you could do a no CDP run. You've also got CDP enable, which is a interface command. So you'd go to an interface and do CDP enable if you just wanted to enable CDP on a particular interface. And if you wanted to disable it on a particular interface, then you do a no CDP enable. Okay. These are just the different fields that we saw in the previous slide. I'll jump to it in a second. Your device identifier saying the name of the device, the port identifier, the local and remote ports that you are connected to the device through. So your local port being your port, remote port being the other device's port. Capabilities list was there's a switch or router, platform of the device, and we saw all of that here. Device interfaces, capability, the platform, the port ID. So we've got all of that there. And our show CDP interface, which is the command we saw here, will show you the interfaces that CDP is sending packets on, hold time on those interfaces. So you can see on a per interface basis what's going on with CDP. All right, our next one is going to be link layer discovery protocol. So here we have LLDP, which is, again, link layer discovery protocol, very similar to CDP, but it works on all devices, not just Cisco devices. Okay, shows you just about all of the information that a show CDP neighbors would, but there is the platform that's missing because they're not all the same company. Then it's harder to detect, and you can't detect really the platform. So everything else is there. You've got a show LLDP, which is just like a show CDP neighbors. You've got a LLDP run to enable LLDP on all device, on the entire device, I should say, just like you had a CDP run. Okay, and you also have a no LDP run, just like you had a no CDP run. All right. The thing that's a little different is when you go to an interface to enable LLDP, we had just CDP enable on an interface using CDP. You have to set up transmit and receive separately with LLDP. So you'd go to your interface, let's say Fast Ethernet 01. You go to that interface, do a LLDP transmit, do a LLDP receive. Then you'd be transmitting and receiving those LLDP advertisements. Okay, again, on CDP, all you had to do was a CDP enable. You have to do actually two on LLDP. So you've got to show LLDP neighbors that you can do, and that's going to look like this. Okay, so what is missing? We have the platform missing. Everything else is there. You got hold time, capability, local port, remote port, same things we saw in the show CDP neighbors command. Okay, I think I might have made a mistake in saying that this was the command to show your neighbors. That's just to show that it's running show LLDP, but this is for the neighbors down here. Okay, the capability, it says B here for bridge, even though it's a switch. In LLDP, bridge can mean switch as well. As far as capability goes, you can see that it's a S2, so that's going to be a switch, but capability still says B, that's okay. All right, so we move on to device management, where we'll see the network time protocol and Syslog. So NTP is going to be important because in troubleshooting and just maintaining your network, having all your devices with the same time, or at least very, very, very similar time, is going to be important. If you have an issue that takes place, you don't want your devices reading different timestamps on a message that might be produced from that issue. Could cause confusion. So you do have two different ways of configuring your system clock, which is, well, one, manually, which could cause issues because you might not be totally synchronized, or you can configure this network time protocol, in which basically your devices share time with each other, okay, and that time is obtained from some NTP server that's somewhat towards the top of this list, okay. So you've got an authoritative time source that is producing the time that gets sent down through this in that NTP server. Okay, and you have different stratums here. Your stratum 0, you can see, is your authoritative time source. Okay, as you move down, you got stratum 1, which would be your NTP server typically, that shares with other devices as you go down the list. For instance, this R1 down here could be considered a R or stratum 2 device because it's connected to the NTP server top level. All right. And then this switch here could be considered a stratum 3 device. It's acting as a server and a client in that it is getting its time from R1, and it's also sharing that time with the NTP clients over here. Okay, so you have different stratums. You don't want to go more than 15 hop counts away. If you're in stratum 16, you are considered unsynchronized. Okay. Stratum number indicates how far from the server the server is from the time source. So that's what the stratum number is there. You've got a couple of different commands. You've got NTP server, which will allow you to configure the server that you want to get your time from. Okay, so you just type in NTP server and then some IP address. I believe we have a graphic on that. No, we don't. Let me insert one real quick. Alright, so here is an example of that command NTP server and just IP address. That's all it is. Okay, you can see what the show clock will give you. For instance, we've got an initial show clock here on R1 in this topology that just shows the time source is user configured. Once you do your NTP server, then you do your show clock, it'll show you the time source is from NTP. So you can see that verification there. The other commands we have are show NTP associations, show NTP status. That's going to show you the device you're getting your time from, also the status of your own device. So we'll see that here. You've got show NTP associations. You can see where you're getting the time from, what the reference clock is, it's GPS. The device we're using as our server in this situation, we are R1. Okay, we're getting our information from this NTP server here. And we are Stratum 1. Okay, we're right next to the, oh no, I'm sorry, we're not Stratum 1. The server is Stratum 1. Okay, it's right next to that time source. Actually, R1 itself is Stratum 2. Okay, and it's referencing this IP address or this server for its time. So that's what you'll see in a show NTP status. So we got show NTP associations and show NTP status here. Okay, so that's pretty much all there is to it. You've got to determine the server you want to get your time from. You've got different tiers here, and you've got your commands that you'll need for network time protocol as well. Not too bad, not too bad. Next we have Syslog. Syslog is a tool that allows us to keep track of events happening on our devices, and they can be sent to different places. They're ranked in level severity. They can be pretty handy in troubleshooting. So what it does, it allows the devices to send their messages to a Syslog server or a couple different locations as well. Supported by most Cisco networking devices. It does log information. You can choose the type of information you want to log. Do you want to log just a certain protocol, a certain interface? You only want certain types of messages sent here or there. You can select the types you want, and also specify the destinations. We've got a couple destinations over here. You can see the logging buffer, console line, terminal line, or Syslog server. So logging buffer would be RAM internal to your device, or you could send messages to the console line, terminal line, or the Syslog server. So those are the different types of different types of destinations you could send things to. You've got a level of severity 0 through 7, 0 being the most severe, 7 being just normal debugging messages. So anything really from 0 through 4, those are error through emergency messages that are going to be logging some type of issue that's going on. Okay, level 5 would be a notification message, and it's normal, but a significant event like a interface going up or down, if a system's restarted, something like that, you'd have as a level 5 message. Level 6 is just information that doesn't affect the functionality of your device really, and level 7 is going to be debug. Okay, you've got your facility, your service identifiers that identify the service in the involved in the format. It could be OSPF, it could be IP. What is the service? You've got a service timestamp. So you've got timestamp debugging and management. There's a timestamp on your messages that get sent through. There can also be a sequence number if that is enabled globally. So those are things you'll have on your messages as well as they're sent across. So the Syslog configuration and the Syslog server and how you set up which messages are going to be set up. You set up which messages are going to be sent to the Syslog server on this slide. So some advantages of the syslog server: it parses the output and places messages into predefined columns. A little messier to read if you're out on your actual device, but on a syslog server, it's easier to read because of those columns in place. Timestamps are displayed if they're configured on your networking devices. Also allows easier navigation of large amounts of data if you have a syslog server set up. And there are various free syslog server programs you can set up on a Windows 7, Windows 10 computer. Your default logging is to send all messages of all severity to your console line. If you want to see the default logging on your device, you can do a show logging that will also show you messages that have been logged as well. So show logging is a pretty handy command. Okay, so that'll show you your default logging, and it will verify the messages being sent. Down beneath that, we've got router and switch commands for syslog. So setting up a router or switch as a client for syslog. You want to send your messages to some syslog server. Okay, so all you're going to do is, you've got logging. This is all global config here, by the way. All of this is global config. So you go logging, then the IP address of your syslog server. Okay, logging, then the IP address of your syslog server, and it's going to start sending those syslog messages that way. You've got a logging trap level. If you don't want to send messages above a certain level, you'd put a level in there, like level 3, level 4. If you put in a level 3, only messages that are level 3 or below are going to be sent to that syslog server. And if you want a certain logging source interface, like gigabit Ethernet 01 or 00, if you want that IP address on that interface to be attached to your messages to the syslog server, no matter which interface your syslog messages come from, you can set that up. This is an optional command. You don't need to use it, but if for some reason you want the same IP address going to the syslog server, no matter which interface that syslog message is leaving from, then you can set that up here with the logging source interface. Okay, again, verifying, we got the show logging, and you can use the pipe just like in multiple other commands. Let's take a look at a couple examples. So if you do your show logging, it will show you your default logging settings. So that's what you've got here, our default logging settings for a router. Okay, so you'll see all of that. You see your log buffer, so on and so forth. Okay, we can see the console logging is on here, and buffer logging is on when we do the show logging command. All right. For setting up your device as a client, you're going to, again, we typed in or saw the commands logging, then an IP address, so this would be the IP address of your syslog server. Your trap level or level of severity that you'd send is 4 or below, and your source interface is going to be G00 in this case. All right. So here's an example of how that trap level is going to work. We've got a interface loopback 1, which is going to configure a loopback interface. You've got a couple different levels of severity here on these events. We've got a 3 that brought this interface loopback 0 online as soon as we did an interface loopback 0. Okay, and a couple other messages that are just notification and whatnot. We shut down that interface, and that shutdown of the interface is only considered level 5. Okay, only considered level 5 here. When we do a no shutdown and bring it back up, that's a level 3. So we've only got 2 messages that are below 4 here that should be sent to our syslog server. Okay, and if we look at the output, you can see that's exactly what we get. It's a little blurry, but you can see that loopback 0 state change to up, loopback 0 state change to up. Those are the only 2 messages that were level 3 severity or below, so that's what we see here. Okay, so that's how syslog works. You gotta set up a server, set up messages being sent to that server, and that's about it. Okay. Device maintenance is what we've got left. This is the last topic in chapter 10. So we're going to be I'm sorry. We're going to be managing your iOS files and how your system boots, how you back up and restore your iOS files in this section. So we're going to start out with a couple basic commands here on router and switch file systems. You can do a show file systems to see the available memory and used memory on your devices. For instance, a router, you'd have the NVRAM, which is displayed, as well as flash memory. Also TFTP, if that's being used at all, would be shown there as well. The bootable memory would have a pound sign next to them. And the default file location or default file directory would have an asterisk next to it in that show file systems command. dir is just going to show the contents of the file system, and if you don't change your directory, it's going to show you the contents of your default file system, or the one with the asterisk next to it when you do a show file systems. Okay. So dir would do that. If you want to see the contents of another location, you can do a cd, then whatever the name of that location is. So let's say I wanted to see the contents of NVRAM. I could do a cd space NVRAM, then do a dir to show the contents of the file system, and it would show me NVRAM rather than some other location like flash. Okay. So that's what cd does, change directory. You're probably familiar with that command from different command line interfaces. If you do change the directory and you want to be sure that you have, you can do the pwd command, which would verify the present working directory, basically showing you the name of the directory that you're currently in. So those are some options for you. As far as backing up and restoring text files, that would be to basically back up your running config or startup config and be able to reload it. So in TerraTerm, in PuTTY, there are options to log your entries. So you would turn on logging, then you would do a show running config or show startup config, whichever one you wanted to capture. Once you've captured that, you would save it through TerraTerm or PuTTY to a text file. Then either directly through the program or through a notepad or text editor, you could copy and paste those commands in. We've gone over how you can use notepad to copy and paste commands before. So same type of process here. Since you've saved your startup config to a text file, you could just simply copy and paste it in. The only issue you might have is some of your passwords may be encrypted, so they won't transfer over quite as well. So you'd have to fix those. But other than that, you can pretty much get your whole running or startup config copied and pasted in using that technique. So that's what's being referred to down here. So Notepad may not be the best way to copy your running config. You have some other techniques such as your TFTP server and your USB flash drive. So, well, all you have to do is you've got your copy running config to TFTP, okay, or copy startup config to TFTP. When you do that, it's going to ask you for the IP address of your TFTP server, and you'll type that in, and it'll send it right over. Okay. If you want to restore from a TFTP server, you just type in copy TFTP running config or copy TFTP startup config. So you just rearrange that command a little bit. Okay. So again, that's just copy TFTP running config or copy TFTP startup to restore. And it's the same type of thing here for a USB. First thing they recommend you do is show file systems to verify that the USB flash drive is being recognized. Okay. Then you can do a copy run USB flash : / and when you press enter, you'll be asked to give the TFTP file a name. Okay. So you'll give it a name, and you'll go on through. Also, I didn't mention you'll be asked for a name here as well as just like in the USB process. So you'll be asked for a name up here and IP address down here. You're just asked for a name. If your flash drive was named something different, then you would type that name in here instead of USB flash 0. Okay. Restoring from the flash drive, if you want to verify that that file is there, you can do a directory for your USB flash and make sure that you've saved your configuration file correctly. And to restore, it's copy and then the name of your flash drive and the file name. Press enter, and that should work. Okay. So again, it's copy, name of your flash drive here, / whatever the file name was you give it, and it'll copy it on back. Okay. So you got that. You don't have the run here. Just copy flash drive and the file name. All right. Password recovery and ROM-mon mode. So if you get locked out of your device, unfortunately, you can recover the device or get back into it via ROM-mon mode. ROM-mon mode can be accessed by powering off your device, holding the mode button as you power it back on for around 15 seconds, and that will get you into ROM-mon mode. During device boot, you can do a control break, I believe it is, with PuTTY, and that will get you to the prompt where you can get into ROM-mon mode as well. You've got to change this register to 21x2142, 0x2142. That 0x2142 basically has your device load without loading the startup config. Okay, since it doesn't load the startup config, you can then make changes to the startup config that is there and save those changes. And you'd have to change the prompt back to what is it? Let me see. It's 0x2102 instead, which does load the startup config, and you'd be back to normal. So you can disable the startup config by typing this in ROM-mon mode. You do a confreg, configure register, basically CONFREG. Okay. Then you type this in to disable the startup config. Okay. In ROM-mon mode, you do that, then type in reset, and that would reset your device without the startup config. Then you can make your changes. You have to go in and change this back to the original value, which is basically change this 1.4 to a 1.0, and you'd be good to go. Okay. So that's what you do to do your password recovery. It's explained a little further in the book or in the online reading. So if you want to take a look at it there, again, it's just a CONFREG space this number. Type reset. That'll get you out of ROM-mon mode, resetted, loading up your device. You can make your changes. When you've made your changes and save them, you can go back into ROM-mon and do a 0x2102 instead of 42. Just change this 4 to a 0. Okay. So that's that, and that's your startup and running config. We're next going to talk about your iOS image. So our iOS system files and how you transfer them back and forth. First of all, there's two different types of system image packaging. You've got your normal universal, then you've got your universal NPE. Basically, you've got your universal has all features. Okay, encryption, all functionality of your device. Okay, VPN, SSL, secure unified communications. It has everything. Some countries require encryption to be limited, though, and in that situation, you've got the NPE images, which are going to not support any strong payload encryption due to country policies. So this will be a little bit more limited. This is going to have all features depending on where you are. You'll want one of these images as you decide to upgrade your software on your device. Okay, you got the different IP technology packages here, and technology packages are activated through licensing the data, the UC, the SEC technology packages. What else do we have? We have the iOS file names. You'll be able to see those and how they're broken down. In fact, we have a breakdown over here of what everything means. It's not just a long, meaningless string of numbers and letters. So you've got your hardware version, your image designation, okay, memory location, compression format, digital signature indicator, major release, minor release, new feature release, extended maintenance release, maintenance rebuild file extension, yada yada on down the list. So there are different segments to each, or different meanings to each segment of the iOS image name. Okay, if you do a show flash, you are going to see just this iOS image name, in case you're wondering what version you're on. So you can do that with the show flash. We're going to go through the process of backing up and restoring your iOS image from a TFTP server in this slide. TFTP servers do act as a backup location, or can act as a backup location for your iOS files. And how you're going to back up and restore in these next two bullet points here. So, steps to back up: you want to verify that you have access to the TFTP server. So whatever your TFTP server's IP address is, you probably want to ping it. Make sure you have enough storage space on your TFTP server, which probably isn't an issue. Then you're just going to do a copy, and then the name of the location you're copying from, whether it's flash 0 or whatever it is, then TFTP : and it's going to look like this. So like copy flash 0 : TFTP : you press enter, you've got a source file name it'll ask for. You go ahead and copy that file name of your iOS image. It'll ask you for the name of the address of the TFTP server. You'll type that in, and it'll go ahead and do its thing. Destination file name as well. It'll give you, press enter, and away it goes. Okay, so that's backing up to the TFTP server. Once you've got that image on the TFTP server, if you need to load it, or maybe you downloaded an iOS image from Cisco.com and you want to transfer it to your device. Okay, if you want to do that, you've got your copy. Well, first of all, verify connectivity, verify sufficient disk space. Then you've got copy TFTP, TFTP : then flash : which is basically the reverse of what we had before here, which is just flash to TFTP, basically from source to destination, the address of the remote host, okay, source file name, yada yada, press enter, it'll send it on through. Okay, in this case we're using IPv6, don't let that scare you or anything. Just using an IPv6 address to send that data across. Okay, so to copy an iOS image to a device rather than backing it up from a device. Okay, if you once you've got that new image in there, if you want to choose the image to boot from, if you have multiple images on your device, you can do a boot system and configure terminal boot system, and then wherever that iOS file is located, press enter, and well, that's it. You've got that there. You could do a copy run start for good measure as well. So those are your processes for backing up, restoring, changing the iOS file that boots on your device. And the last thing we have here is software licensing. So purchasing stuff and making sure it's licensed. So if you need to upgrade your software on your device, you can purchase software from Cisco or wherever you need to. And once you purchase the software, there's a couple things you're going to need to obtain a license. Okay, you've got to use your Cisco License Manager, or you've got a Cisco License Portal. Cisco License Manager is a program that you can use, graphical user interface. Cisco License Portal is going to be a web-based interface, also graphical, that you can use to obtain a license. Okay. To obtain that license, you're going to need this UDI. Okay, that's a combination of the serial number and the PID, product ID, on your device. You can find that on a card within the device, or if you do a show license UDI, you will find that information in the command line of your device as well. Okay, so once you obtain that license, you're going to do a license install, and then just wherever that license is installed at, you'll probably have an XML file of some sort on your device. You're going to point out that location, which would be a flash 0:, and then that file, maybe it's on a TFTP server. Wherever that file is, you're going to need to do a license install and install that file, then do a reload. So license verification and management. You've got a show version, which is going to show you the version that you're on, and some information there that will show you which licenses are activated. You've got a show license that's going to look like this. It will show you the time you have left, the state that these licenses are in, so you can see which licenses are activated there as well, the show license. Activate an evaluation right to use license. You can go license accept and user agreement. Then the module name and the package name, it's going to look like this here. So license accept and user agreement, license boot module, yada yada, technology package, blah blah. So whichever it is that you're activating, you're going to have to type in there. Okay, so again, that was a license boot module technology package something. So license boot module C1900 technology package data K9. Okay, so that's how you would activate an evaluation or right to use license. If you do activate that, it's going to show up like this, show you how much time you have left, and that it is an evaluation right to use. Okay. If you need to save the license, let's see, I think we have that here. Yep, license save, flash 0, all licenses, something like that, .lic. That will save all your licenses for you, or back up your licenses. Okay. Disabling your licenses. You've got license boot, basically disable. You'll name a license and disable it, or you can clear a license. So that'll look like this: license boot module blah blah package blah blah disable, or you've got license clear that license, or no license boot module blah blah blah. Okay, so if you want to clear them, you can. If you just want to disable, that's this option up here. Alright, so there's a difference between clearing and disabling. You can re-enable if you've disabled. Clearing clears everything out. Okay, so there's that, and that's about it for the license verification. And that's about it, I think. Period. It is. So, a few topics here. Probably not the most important. CDP and LLDP network time protocol, they may show up. The licensing seems a bit lighter. But we'll discuss that and the things that will be coming up on the CCENT in class. So this is our last video. We'll be getting ready for the final at the end of this week and next week.